Welcome back. Welcome back to the second section of the video for 9.2. In this section, we're going to learn to find partial sums of arithmetic sequences. That means, well, let me tell you a story. You'll see what it means. In the early 18th century, there was an incredibly gifted mathematician called Carl Friedrich Gauss. He's one of the top 5 mathematicians in probably all of history. Gauss, G-A-U-S-S. And when he was a kid, the story goes, I don't know how true it is, his teacher was really annoyed with him because he kept solving all the questions too quickly. And he always was like, I'm done. So one day his teacher said, all right, smarty pants, sit back down at your desk, grab this slate and this piece of chalk and add up all the numbers from 1 to 100. Because the teacher thought, well, that'll keep him busy for a while. Well, about 28 seconds later, good old Carl comes back up to the teacher and says, I'm done, teacher. The sum of the numbers from 1 to 100 is 5,050. And his teacher's like, oh, how did you finish so soon, you annoying little child? Well, I'll tell you how he did it. So take a look at this sequence right here. This is an arithmetic sequence written as a series now because I'm adding them up. How long would it take you to add up 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 all the way up to 100? Well, Carl Friedrich Gauss's teacher thought it would take him a long time, but it didn't take Mr. Gauss very long at all. Can you see what he did? Well, here's what he did. What do these two add up to? Well, 5 and 96 add up to 101. And what about 4 and 97? Well, they add up to 101. And what about 3 and 98? Well, they add up to 101. And what about 2 and 99? They add up to 101. And then what about 1 and 100? They add up to 101. So what Carl Friedrich Gauss realized is that, well, I don't really have to do much work here. I know that if I put these numbers in pairs, these pairs always add up to 101. So all I need to know is how many pairs are there? Well, if there are 100 numbers, how many pairs do you have? 50. And therefore, the sum must be 101 times 50, which is 5,050. That's how he added up the numbers from 1 to 100 in about 25 seconds. See, it wasn't hard if you look at it the right way. So what basically we have here is we have a general formula for this. We can say that to find the finite, in other words, not infinite, the finite sum of any arithmetic sequence, we can just use this formula. This n stands for the sum of the first n terms will equal n over 2 times the first term plus the nth term, which is the last term. Now think about that. In this particular case, the one we just did, that would mean that the sum of the first 100 terms is n, which is 100, over 2 times the first term, which is 1, plus the last term, which is 100. Do you see how this formula is exactly what we ended up doing, 50 times 101? Because we're dividing by 2 because we're taking them in pairs, and then we're just adding them together. All right, so let's try using that formula. Let's find the sum of these guys. All right, so we're going to use this guy. The finite sum of an arithmetic sequence is always going to be this formula right here. So in this particular sequence, I know what the first term is, it's 1. I know what the nth term is, it's 23. I just don't know how many terms there are. So I'm going to have to count it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 terms. So to find the sum of the first 12 terms of that sequence, which is now a series, I will basically have 6 pairs of numbers whose sum is 24. Check it out. If I take the first term, 3 and 23, they add up to 24. If I take the 3 and the 21, they add up to 24. The 5 and the 19, they add up to 24. So there are 6 pairs that add up to 24. And therefore, the sum is going to be 144. Cool, huh? So I would like for you to try, if you can, to pause the video and see if you can do it. Try finding now the 150th partial sum of this particular series. Now think about it. If you want to know the 150th, I didn't tell you what the 150th is. You're going to have to find that first. So pause the video and see if you can do it. Here's what you should have done. So the first thing you have to do is you got to find the 150th term. Now to do that, we're going to use the formula we just learned in the previous video. And so the 150th term is going to equal 4 plus the common difference, which in this case is 10, times n minus 1, which in this case will be 149. So I can note that the 150th term is 1,494. Okay, once I know that, I can then go ahead and find the sum of the first 150 terms. So I'm just going to use this formula right here. So I'm going to have 150 divided by 2, 75, because I have 75 pairs now. And the first term is 4. The last term was 1,494. So I'm going to have 75 pairs of numbers whose sum is 1,498. Now, of course, that you're going to have to put into a calculator unless you're Mr. Peretti. Let me see. I'd say it's about 112,000. Probably 112,350 off the top of my head. I think that's probably about right. Okay, let's do a few more examples and then we're done for this week. It's an easy week, isn't it? Last page. After this, I got no more. All right, example 3, find the 20th partial sum of this guy. All right, this one's not too different, but once again, it's the 2 steps that we did in the previous one. So hopefully you guys can do that. First, you're going to have to find the 20th term. To do that, we're going to take the first term and add the common difference. Now be very careful on this. This thing is going up by 10 and times 19. So the 20th term is going to be 95. Now think about it. If the first term is negative 95 and the last term is positive 95, what do you think the sum is going to be? Well, let's keep going. So using the formula 20 divided by 2, the first term plus the last term. Oh, well, this isn't looking very good for us, is it? So there are 10 pairs, and each of these pairs add up to 0, and therefore the sum will be 0. It just so happens that negative 95 adds up with positive 95, and negative 85 adds to positive 85, and negative 75 adds to positive 75. So all of our pairs equal 0. So the sum of this one's actually going to be 0. Kind of weird. Okay, so now let's take a look at one more example where we have the notation that we learned last week. So perhaps what we would like to do is, first of all, go ahead and write this out. Let me get my notes. Well, I don't have this one in my notes. All right, good enough. So let's go ahead and figure out what this is. So let's plug in 1 for n, and we will get 2. And let's plug in 2 for n, and we will get 5. Let's plug in 3 for n, and we will get 8. All right, so it's arithmetic. Now let's cut to the chase. Let's go ahead and plug in 50, which is the last term we want. Plugging in 50, I will get 149. So there are 50 terms in this series, which means I'm going to have 25 pairs, and each of the pairs is going to add up to 151. So to find the sum of this guy, the sum of the first 50, I'm going to do 50 over 2, that's my 25 pairs, times the first term plus the last term, which gives you 25 times 151, which gives you, I have no idea what that gives you. It gives you something. Well, for some reason, I don't have that one in my notes. So I'm going to go ahead and let you put that in a calculator, and it gives you whatever it gives you. Okay, and the last example. This one's kind of cool. An auditorium has 30 rows of seats, and each row has 2 more seats than the row in front of it. The first row has 22 seats. How many seats are in the auditorium? So just to draw a little picture, here is your screen or your stage, and the auditorium's coming out. And here in this first row, there are 22 seats. And in the second row, there are 24 seats. And in the third row, there are 26 seats. And then there are 28 seats all the way back, and there are 30 rows. So it wants you to know how many seats there are. Well, you probably figured this out, but all we're trying to do is add up this arithmetic sequence. We're trying to add up 22 plus 24 plus 26 plus 28 plus blah, 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 whatever is in the 30th row. Now, this is, of course, a sub 1. I don't know what a sub 30 is, but I can certainly figure out what a sub 30 is. Let's do that now. So a sub 30 is going to equal a sub 1 plus the common difference, which is 2, times 30 minus 1, which is 22 plus 2 times 29. That's 58. So in the last row, we're going to have 80 seats. That is the last row. We're going to have 80 seats in the last row. So now I can figure out how many seats there are in total by using the summation formula. So let's see, there are 30 rows, so 30 divided by 2 times the first one, which is 22, plus the last one, which is 80. And this I do have in my notes. It is 1,530 seats. So you're going to have a few word problems in there. I think one of the questions has to do with bricks, and the other question has to do with some baked goods or something like that. But you're going to have to kind of draw a picture and figure it out and use these formulas. Okay, guys, this week's pretty easy. You should be able to do this in less than 2.5 hours. If you have questions, as always, please ask. I'm here to help you. There should be no reason that all of you don't end the school year with an A. All right, see you later.